Welcome back, physics students. We are going to go over review number 1 in position time graphs and velocity time graphs of two cars. So we have car A that's going in that direction and car B that's going in that direction. We'll talk more about what that direction is. So to find the mathematical model of both cars, we have to remember what that mathematical model is. So we're going to have XF, which is final position, is equal to velocity times time plus initial position. And so remember, velocity and initial position are information that we can find in our position time graph. So to find velocity, we're going to find 2 points, any 2 points. And so I'm going to choose this point right here at 2 seconds, position 10, and 0 seconds and 1 meter. All right. So then we have 10 meters minus 1 meter over 2 seconds minus 0 seconds. So when we do the math, 10 minus 1 is going to be 9 meters, and 2 minus 0 is going to be 2 seconds. And so 9 meters divided by 2 seconds is going to give us 4.5 meters per second. So the velocity of car A is going to be 4.5 meters per second. And the Y-intercept, or the initial position, is going to be right here. And so final position is equal to 4.5 meters per second times time plus initial position of 1 meter. Now car B is going to have 2 points that we're going to pick also for the velocity. And so we're going to pick right here, 2 seconds. 2 seconds is going to be 2 meters. And then over here at 0 seconds, it's going to be at 8 meters. So we're going to use these 2 points to calculate our velocity. 2 meters minus 8 meters is going to be whatever that number is over 2 seconds minus 0 seconds. So 2 minus 8 is negative 6. And over 2 seconds. So it's negative 3 meters per second. Next, we are going to look at the Y-intercept, or the initial position of car B. And so final position is equal to negative 3 meters per second. And so remember that negative 3 meters per second means that the velocity is at 3 meters in the negative direction, plus initial position of 8 meters, because that's where it is at time 0. And so this is our mathematical models for cars A and B. So just a reminder, velocity is right here that we calculated. We calculated the slope of the graph on a position time graph to get our velocity. And we looked at time 0 to get our Y-intercept. All right, so now let's go ahead and go to the bottom. We're going to look at the velocity graph. We're going to label our graph, and we're going to also put in our information. So on the y-axis on the velocity time graph is the velocity in meters per second. And then how to number it, I'm going to take a look at what my velocities are, 3 meters and 4.5. So it doesn't go past 6. I'll just pick to go by 2. So 2, 4, 6, and then negative 2, negative 4, and negative 6. So let's go ahead and graph our velocities. I'm going to go ahead and graph the car B's velocity first. So it's negative 3 meters per second. So it's going to be right here between negative 2 and negative 4. And then draw my straight line because the car went at negative 3 meters per second for 2 seconds. And then for car A, I'm going to find 4.5 meters per second, and it traveled at 4.5 meters per second for 2 seconds. So this straight line goes all the way across 2 seconds. And here we can see car A's velocity in the red, And we can see car B's velocity in the blue. And we can find the velocity on the y-axis. So we just look across on the y-axis on the velocity time graph to find out what the speed is of the cars. So then car B's velocity over here is going to be -3. And it was -3 throughout the whole run. So now we're going to go ahead and look at where and when the cars will meet. And so right here at this yellow dot where the red line and the blue line intersect, we see that it intersects approximately right before 1 second and right after -5 meters. So at that moment in time, at that location, that's where those two cars met each other. And so the cars will meet each other where the lines intersect, where the intersection of the lines on the graph. And that means that they're at the same place at the same time. It does not mean that they're necessarily crashing. They're just passing each other as car A goes in the positive direction and car B goes in the negative direction. So they will be at the same place at the same time. That's what that intersection of those two lines means. All right, so we can just make some approximation of where and when that happens. So looking at the graph, it looks like it's about, let's see, 1 and then -0.2, 0.4, 0.6, 0.8. So this must be around 0.95 since it's closer to 1. And for position, we see that it's about a little past 5 meters, right? So we can say, I don't know, 5.2. So car A and car B will be at the same place at the same time at time 0.95 seconds and position 5.2 meters. Now we're going to look at red car's position, the final position, to be at time 60 seconds. So we have final position is equal to the velocity, which is 4.5 meters per second, times the time, plus initial position of 1 meter. All right, so now we're going to replace time with 60 seconds because that's what the question is asking for us. So 4.5 meters per second times 60 seconds plus 1 meter. So 4.5 plus 60 is going to give us 270 meters. So 4.5 multiplication 60 is going to give us 270. So 270 meters plus 1 meter from the initial position. So that's going to give us 271 meters. And that is it, folks. If you have any questions, please make sure to email your teachers and let them know.